In this video, we'll look at balancing chemical equations and see a few examples. When we write a chemical equation, we're explaining what happens in the reaction. It shows our reactants, what we start with, and the products that we form. And then we have an arrow indicating which direction the reaction is going. So we have the arrow always pointing from the reactants to the products. And we draw the reactants on the left-hand side and the products on the right-hand side. And whenever we do a chemical reaction, we have to make sure it's balanced. That means we can't create or destroy matter. We have to remember our law of conservation of matter, where it cannot be created or destroyed, it just changes form. So that means every element we start with and the number of elements we start with are the same that we have to end with. And another important thing is when we write our chemical reactions, we always indicate the state of a reaction. So if we're looking at the combustion of methane, methane is a gas, so we write G for gas. And then oxygen is a gas as well, so we write G for gas. If we remember our different states, G is how we represent gas, L is how we represent liquid. I always write my L for liquid in cursive because otherwise it looks like I'm just writing a line. It could be a 1. S for solid. And then if it's dissolved in water, we write AQ for aqueous. So one of these 4 states is what you have to put in parentheses after each compound. And then once you do that, now you have a good chemical equation. So looking a little closer at balancing our chemical equations. As I said, remember matter cannot be lost during a chemical reactions. So the number of elements on the reactant side has to equal the number of elements on the product side. And one important thing when you're balancing equations, you only change the coefficients. Only ever change the coefficients. Don't touch the subscripts. If you change the subscript, now you've changed which compound you're talking about. So never, ever, ever touch your subscripts. And then so the products are going to have to account for all the atoms in the reactants, and always double check yourself. It's always good to double check it to make sure you've balanced it properly. If you don't balance it properly, that can cause issues for you later on when we learn how to do calculations and do stoichiometry. So looking at a couple examples. Let's say we have iron plus sulfuric acid. That gives me iron sulfate plus hydrogen gas. So if we look at our equation here, we need to figure out what all the coefficients are. For me personally, I find it easiest to kind of keep a little table on the side to keep track of what's on the reactants, what's on the products. So if we start going down our list, I have iron on both sides. I have sulfate on both sides. You see there's SO4, SO4. If it's a polyatomic ion, they tend to be easiest to balance if you keep them together. So I'm going to keep my sulfate together just to make my life a little bit easier. And then you see I also have hydrogen. With the hydrogen, I want to write as just an H, not an H2, because sometimes you might end up with like just one hydrogen instead of an H2, and then it becomes a lot harder to balance. So you want to write the elements by themselves as individual elements, unless it's a polyatomic ion. So we have our reactants and our products. So now I want to fill in the number I have on each side. For the reactants, I have 1 iron And on the products, you see I have 2 irons. Obviously, they're not balanced. Then I look at my sulfates. On the reactant side, I have 1 sulfate. On the product side, I have 3 sulfates. Again, obviously not balanced. Then the hydrogens, I have 2 on the reactants, and I have 2 on the products. Hey, that one's balanced. One other thing, if I have an element by itself, like my iron on the reactants here, since it's by itself, I'm going to save that as one of the last ones to balance because it's easiest to add a number in front of that iron than it is to start switching everything else around. And now also, if you're a more visual person, you can draw out everything underneath it. So you see I have 1 iron, 2 hydrogens, 1 sulfate, 2 irons here, 3 sulfates, and 2 hydrogens. Either way works. Table is takes a little bit less space, but if you're more visual and you need to draw it out right now, go for it. So since iron's by itself, I'm going to save that for the last to balance. I'm going to look at my sulfates and try and balance those first. I have 3 sulfates on the products and only 1 sulfate on the reactants. So I'm going to want to have 3 sulfates on the reactant side. To do that, I'm going to try and put a 3 in front here. Putting that 3 in front indicates I have 3 times 2 hydrogens, so now I have 6 hydrogens, and I have 3 times 1 sulfate, so now I have 3 sulfates. So if we were to fix that in our table, I can cross that out, put a 3, cross out my hydrogen there, put a 6. You see it screwed up the balancing of the hydrogens, but I can always go and fix that too. Or if we're more visual, 3, 4, 5, 6 hydrogens, and 3 sulfates. So if we look at our hydrogens, I have 6 hydrogens here and only 2 hydrogens here. So if I change the coefficient to give me 6 hydrogens here, then I can balance them. So if I put a 3, now I added 6 hydrogens, and I haven't changed anything else. So that means I can switch that to a 6. So then my last one I have to balance is my iron. We can see I have 2 irons here and 1 iron here. So if I put a 2 in front, then that would give me 2 irons. If I got a 2 in front, now I have 2 irons. And I can switch that in my table as well. So now I can see with our balanced coefficient, with our balanced equation, we have 2 irons plus 3 sulfuric acids gives me 1 iron sulfate. We don't need to write the 1 here, and 3 hydrogens. And then now if we were to also include our states of matter, iron by itself, since it's an elemental form, is a solid. Sulfuric acid is aqueous. Iron sulfate would be aqueous, and hydrogen would be a gas. So now I've included all my states of matter. I have a balanced equation. This is a good equation to have. Check mark. You always want to first write the correct formulas. So write the correct chemical formulas. If you don't write the correct formulas, balancing is going to be very difficult. And then second, when you first start balancing, I recommend trying to balance your metals or your polyatomic ions first. Then after you balance your metals and your polyatomic ions, you go for your nonmetals. And then finally, if you have an element by itself, So if we say it's a single element, save that for last. It's easiest, as you see, just change the coefficient in front of the element by itself than it is to go and try and switch everything around over and over. And then last, always double check. If you use the table, you can double check by kind of re-adding up all the elements, or you can draw them underneath, just make sure you can see everything's exactly the same. Everything adds up. It's up to you whichever one you want to do, just as long as you're able to balance your chemical equations.